Here is the next question, number 17. Two perfectly matched silicon transistors are connected as shown in the figure. The value of the current I is, so we have our four options, 0, 2.3 milliamps, 4.3 milliamps and 7.3 milliamps. Okay, so here in this case, we see that there are two silicon transistors that are connected, and on the left side we have a resistor of 1 kilo ohms. Now the current that is passing through the 1 kilo ohm resistor is IR, and the current that is passing through the transistor here through the collector is IC1. On this side, the same current that is passing through the collector side of the transistor is IC2. So practically we will have to find out what IC2 is, because that is I given to us. And the beta values for both is 1000. And here we have a voltage of +3. On this end we have -5. And over here we have 0.7 at node B. Now I'm calling that node as node B. Okay. So the first step is to calculate the current that is passing through the resistor over here. Okay. So I'll write down the formula, the direct formula. So the current through the resistor is equal to the difference in the voltage divided by the resistance R. Now the difference in the voltages in this case is the voltage over here at base and the voltage over here -5. So at base here you will see that there is a positive value here and a negative value over here. So minus of -5 minus 0.7 is the difference. So that's 5 minus 0.7 divided by resistance is 1K. So if you solve this part, we will get the current that is passing through the resistance, which is, it comes to 4.3 into 10 power minus 3 amps. This is the current of the resistance. Now, because we will have to calculate the current of the collector side of this transistor over here, let's use the following formula. Let me just grab another sheet of paper. Okay. So to find the equation, we can write down the formula as IC1. That is what we need over here. Okay. That is written as beta divided by beta plus 2 into IR. For this specific circuit, to find out what is IC2, IC1 is anyway equal to IC2, so they are the same. Okay, IC1 will be equal to IC2. So the formula is beta by beta plus 2 into IR. So what do we have over here? IC2 is equal to 1000 divided by 1000 plus 2 into IR, which is 4.3 into 10 power minus 3. Now you will notice over here that beta is very high, right? So we see that beta value is very high. So in that case, the part which is synthesis can be easily ignored, and we will be left with the value of 4.3 into 10 power minus 3. So IC2 value is the same as IC1 value, which is also the same as the current that is passing through the resistance, which is 4.3 milliamps. So this is the final answer. Now the key over here is to note the value of beta. Now because the value of beta is really high, so the current of the collectors of both transistors will be equal to the current that is passing through the resistance. So in this case it is 4.3 milliamps, and that matches option C. Well, this is the entire solution, and I hope it has helped.